Hi, my name is Bob, được mình Lã, and in this video I will explain how I have done the task 7.3 on the ultrasonic sensor. So basically to begin, you need to understand how the ultrasonic sensor actually works. So ultrasonic sensor basically, the idea behind actually to send a sound way over and it's gonna hit the object and the sound will bounce back and there will be a receiver over here. Therefore you actually can collect the time, and from that you actually can know the distance. Alright, so that's the basic idea. So how the sensor actually work? So light sensor, it basically will have three, mainly we have three parts, which is the ground, the VCC for the power, and the signal. But because this is special sensor, we have the send and the receiver. So actually have four parts. So which would be the echo, which over echo is on this side, and the trigger on the right hand side over here. So it will be in the middle. So to actually set it up, basically you need to begin with the ground and the VCC. So the VCC will actually on the right. So VCC on the right, you connect with the positive one on your breadboard. And on the breadboard, you actually connect over here to the Raspberry Pi. So done. The ground, same. Connect to negative one. From negative one, you connect to the ground on the Raspberry Pi. Just go see over here. And that's round one. So after that, here's the tricky part. Is the echo one. The echo will actually be like the receiver. So actually you need to carefully set up. So it's very special because it actually requires two resistors. So first resistor over here is begin, it connect with the sensor, and then it connect with the wire, actually connect to the Raspberry Pi with the wire color over here, and then there's another sensor. We have different ohm to actually connect back to the ground on the negative side. You see over here. And the next one is trigger one. Trigger is just basically connect to another pin. So for the echo one, I connect with the pin number 17, and for the trigger one, this one, I connect to the pin 23. Alright, and next one I connect with the line with the LED. So the LED basically I have for the long leg, so connect with the pins, connect with pin number 20, and another one which actually connect with resistor, connect back to the ground. So that's how the LED will be combined into the system. So that's how I can set up the system. Here is the code. So the code basically is the style we import the library for Raspberry Pi and the time, and set up with the breadboard with board, and set up the pin which trigger, echo, and LED to make it more easier and user friendly. So as you can read it later, you set up which as the output, which as the input. So echo be input, trigger be output, and the LED of course be output. Here how we actually can calculate the distance. So like I say, you actually can see because it's bound by the sound wave, so you actually have to basically have the signal up, like can it actually detect the sound or back or not. So from that you actually can trigger time. That's why we need time library. We have time over here. So when the input echo equals 0, so it start the time, and the echo 0 to 1, it stops the time. So that's how you have the time for start and stop. And then you calculate with distance equal to stop minus start, and multiple by 17,000. We actually we have back the distance in centimeter, and that's how you finish your function for calculate distance. So here's the main one. So what I choose, so I already also print out the distance over here, so as you can see the distance on the terminal. Also, I also have like a small part over here to make the LED blink. And the closer the object, the LED will blink faster, and for the LED blink slower. That's how that would be actually a way to actually know how the system works. And of course here time sleep, so actually it will measure every single second. And also I have put a keyboard interrupt over here, so when you press Ctrl C, it will stop the system. That's how I code and set up the system for this task 7.3. Thank you.